So to find that distance away, this angle of 27 degrees, since the horizontals are going to be parallel to each other, this is also 27 degrees down here. So we have a right angle here because this is a vertical dimension, and vertical and horizontal are always perpendicular to each other, make a right angle. So that's the first step when we look at these situations, is we need to find a right angle. And one of the places we can find that right angle is the intersection of vertical and horizontal dimensions. So we found that right angle. So in this right triangle, we have 190 degrees here, or 190 feet here. According to our 27-degree angle down here, what side of the triangle is the 190? That is the opposite. It forms the right angle, so it's one of the legs, so it's either opposite or adjacent. It's not next to the 27, it's across from it, so it's the opposite side. We're trying to find this purple side up here. Which side of the triangle is that? Hypotenuse. What trig function uses opposite hypotenuse? Cosecant does, and also the sine does. Sine of theta, sine of an angle, is opposite over hypotenuse. So let's fill in what we know with that. Do we know the angle? Yes, that's the 27 degrees. Do we know the length of the opposite side? That's the 190 feet. Do we know the length of the hypotenuse? No, that's what we're trying to find. We'll call that x. Since we are looking for a side of this triangle, we're looking for a missing side, we turn this into a proportion by putting the trig function over 1, and then we will cross multiply and divide. So 1 times 190 divided by the sine of 27. So 1 times 190 is 190 divided by the sine of 27 degrees. So we get 418.51 feet. So if his walkie-talkie has a 500-foot range, he can still say goodbye. Or goodbye. Sorry, Jasper. It had to be done. Any questions on that problem? So let's say we have a circle here that has a diameter of 80 feet. We've got a length here of 140 feet, and this here is 40 feet. We want to find the area of this. How would we find the area of this shape? Well, we need to find right angles for finding right triangles. Remember, we said the first step is vertical and horizontal dimensions. Well, we have that here. This is horizontal and this is vertical. That's already marked as a right angle. The second place where we can find right angles, if we have circles, it's where a radius intersects a tangent. Remember, a radius to a point of tangency always forms a right angle with that tangent. So this radius right here forms a right angle with that tangent to the circle. Well, there's a radius right here as well that's going to form a right angle to that tangent to the circle. What is this length here? 40 feet. Where'd that come from? Half the diameter. This here is also 40 feet, by the way. Well, if I cut this across here, what do I know about that shape? It's a rectangle. This shape is a triangle. This is 40 feet here. Do I know any other dimensions of this triangle? the hypotenuse, which is 140. If that's a rectangle, opposite sides are the same. So now there's a couple of things I can find. I need to find the length of this side. How do I find the length of that side? A squared plus B squared equals C squared. I'm going to take a shortcut. Square root of 140 squared minus 40. 140 was the hypotenuse, right? So we get 134.16 feet. Now we also need an angle. We know this is 90 degrees. I need to know that angle there. How would I find that angle right there? I'm going to call that angle A. I'm going to try to avoid using the 134.16 for two reasons. One, we just calculated it, and we may have made a mistake. Two, even if we didn't make a mistake, it's rounded, right? It's not really 134.16. It's 134.164078, blah, 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 blah. So we don't know that exact number. It's rounded. So we want to use the numbers that we were given, the 40 and the 140. So according to angle A, the 140 is which side of that triangle? Hypotenuse. The 40 is it's next to the angle, so it's the adjacent. So adjacent and hypotenuse is cosine. Cosine of an angle is equal to the adjacent over the hypotenuse. Let's plug in what we know. Do we know the angle? No, angle A is what we're trying to find. The adjacent side is 40 and the hypotenuse is 140. Now here we are looking for the angle. Up above we were looking for the length of the side. If we're looking for the angle, we do what? Inverse trig function. It's cosine, so we do an inverse cosine. So angle A is the inverse cosine. The inverse cosine and the cosine cancel out here. 40 over 140. So second cosine, 40 over 140. 73.40 basically. So we're at 73.40 degrees there. Now we are prepared to find the area. To find the area, we've got three sections here. I'm going to do section 1 first. It's a rectangle. How do I find its area? Yeah, 140 times 40, which is 5,600 square feet. Look right. Section 2 is a triangle. How do I find its area? Which two sides? Which are? There we go. That's why I needed the 134.16. 40 feet by times 134.16 divided by 2 because it's a triangle. 2,683.2 square feet. Look correct? Section 3 is going to require a little more work. Section 3, we're going to start off by finding the area of the whole circle, which is pi times 40 squared, the radius squared. That's the area of the whole circle. But we don't want the whole circle. We just want a section of it. That section is defined by this angle. That angle is going to be 360 minus 90, which is 270. What else do I have to subtract from it? 73.40. You got it. Which is 199.60 degrees. Yes. 196. What's a few degrees among friends? 196. Thank you. So 196.6. So 3.14 pi times 40 squared times 196.6 divided by 360. 2743.66. square feet. So we add those all together. Yes, you do get the total area, which is 10,026.86 square feet. What do you guys think? Oh, come on now. This is fun stuff. Okay, you guys got everything down? So let's say that this angle right here is 70 degrees. This triangle up here has a diameter of, a triangle, this circle up here has a diameter of 120 inches. Find the area of that whole figure. I'm gonna give you guys a couple minutes, see what you find. Okay, so your first triangle, you're gonna find the radius of the circle. Both of those are right angles. So this is 60 inches here, 60 inches here. Now, one of our rules of circles that we learned is if I connect this out here, that divides this into two. Obviously 60 is equal to 60, right? And that side's equal to itself. Since these are right angles, if two sides are the same, the third side has to be the same, right? So these two triangles are equal, which means it cuts this angle here in half, 35 degrees and 35 degrees. So what I have, if I draw out that triangle a little bit bigger, I have a 35-degree angle here, a right angle there, and 60 inches here. What's this angle up here have to be? What's this angle have to be? 55. How do we get 55? 90 minus 35. Good. 90 or 180 minus 90 is 90. Minus 35 is 55 degrees. We know the 60 here. It would help if we knew that dimension right there. How do we find that dimension? Tangent of theta equals opposite over adjacent, right? Which angle do you want to use, the 55 or the 35? The 55 works for me. Tangent of 55 degrees, what's the opposite? That's the one we're missing, right? We'll call that opposite. The adjacent is the 60. Since we're looking for a side, we'll put the trig function over 1, and we're going to cross multiply and divide. So this is the tangent of 55 times 60. Divided by 1 doesn't do anything, so we won't do it. 85.69. So this is 85.69 inches here. So now I can find the area of that triangle. If I call that 1 and 2 are going to be the same, and we'll be able to find the area of piece 3. 1 and 2, this is going to be a triangle that's going to be 60 by 85.69 divided by 2, and then there's 2 of them, so we'll multiply by 2, right? So obviously, I'm just going to cancel out the dividing by 2 and multiplying by 2. So 60 times that previous answer is 5141.33. That is in inches squared. Now to find section 3 up there, what do I do? So I find the area of the whole thing using the radius. So it's pi times 60 squared. And then it's going to be times this angle here, which is how big? Well, 360 minus 55 and minus 55. Yeah, minus 110. 250 degrees. So that'd be 250 degrees over 360 degrees. So 3.14 times 60 squared times 250 over 360 is 7850. We add those up, we get a total. 12,991.33 inches squared. What do you guys think? Sure. No, these right angles here, because these are tangent to the, I said that these are tangent to the circle. So because those are tangent to a circle, a radius to the point of tangency is always a right angle. I'm gonna have you guys try one here. They have to be tangent for that. Yes. Let's say you guys have a dowel. You want to take that wooden dowel and you want to put a flat surface on it, right? You want to mill it flat. So what you're going to do with that wooden dowel is you're going to actually put it in what's called a V block and clamp it down. Then you're going to take it to a mill, which will actually just take the top edge off of that piece of dowel. So what we need to do, let's say this is a 1.5 inch diameter dowel. This V block here, let's say that this is a 60-degree angle. And from here to here is 1.25 inch. I want to know what is the height to the top of that dowel from the bottom of the block. We're assuming this is symmetrical, yes. Not necessarily, no. I'll give you a second, see what you can think of. Okay. Anybody have any ideas on it? Where'd you start? So the radii out to the tangents to make right triangles. Then we've got this triangle here. What dimension, or we draw it from the center down to the point of the V to make triangles. What do we know about those triangles? This is a 30-degree angle because it's half of the 60. We know this side is 3/4 of an inch. Then of course we can subtract to get that this angle is 60 degrees. So we've got 3/4 of an inch here, 30 degrees. We really want this side is all we want. How do we find that? Well, according to the 30 degrees, this is the opposite, and this is the hypotenuse, which is the sine function. We fill in what we know. Our angle is 30 degrees. Our opposite is 3/4 of an inch. Our hypotenuse is what we're looking for. Cross, multiply, and divide, you get that hypotenuse is 1.5 inches, correct? So you got 1.5 inches here, from there to there. 1.25 inches here. 3/4 of an inch here. That adds up to 3.5 inches. Oh, you did the 60 and used cosine. That works. Yeah. That would give you this. That's not going up and down. You'd have to have done a squared plus b squared equals c squared to get that. Yeah. Okay. In your book, I'm going to let you have the next 11 minutes or so to work on page 743, exercise 35-1. We'll go 3 through 13, the odds. Work on those, and we'll talk about those a little bit here at 10:30. Let's take a look at some examples, guys. Here we go, guys. So we're looking at a tapered table leg. Tapered means it's round, has a larger diameter on one end and smaller diameter on the other end. Right, gentlemen? So let's say that at the table, it has a 4-inch diameter going down to the floor where it has a 1 3/4 inch diameter. The length of the leg is 32 inches. What we want to find is the taper angle. There's two ways to look at the taper angle. Probably the simplest way is this. If you look at this being a cylinder going all the way up through that circle on the bottom, look at it being a cylinder going all the way up through the leg. It's the angle between the wall of that cylinder and the outside of the leg. That, of course, is forming a triangle here. There's my right triangle right there. If I draw my right triangle out here further, do I know any of the dimensions of that right triangle? Try again. There we go. So this length on top up here is the difference between the radii of the circles. So the radius of this circle up here, if it's a 4-inch diameter, it's a 2-inch radius. The radius of this one down here, if it's 1 3/4 inches, if it's 1 3/4 inches diameter, what's its radius? What's 1 3/4 divided by 2? 7/8. So a 2-inch radius minus a 7/8 inch radius gives us 1 1/8 inch. Do we know any other sides of that triangle? Yeah, this is 32. So I can find that angle using those sides. If I have any two sides of a right triangle, I can find the missing angles. So according to that angle, the 32 is which side? Careful. It touches the right angle, so it's either opposite or adjacent. Adjacent. How about this one up here? That also touches the right angle. So it's a leg that has to be the opposite leg. What trig function is opposite adjacent? Tangent is opposite over adjacent. Well, let's plug in what we know. We still don't know the angle. Opposite is 1 1/8, and the adjacent is 32. We are looking for an angle, so you're right. It is an inverse trig function. It is tangent, so we use the inverse tangent. So theta is the inverse tangent of 1 1/8 divided by 32, 2.013 degrees. So that's that taper angle. It's a 2-degree angle. That's it. Sounds like it should be bigger than that, but it's not. Okay, gentlemen, for this problem, what I want you to find is the distance between, again, we have this V block. These are dowels that are set in there. I want to find the distance between them. I'm going to give you a minute and see if you can do that on your own. Okay, so we need to find some distances here. We need to find this distance right here on both sides. It's going to be the same on both sides. We're going to find it by doing this triangle. What's this angle right here? 50 degrees. This is horizontal, this is horizontal, they're parallel, so those angles are the same. We know this dimension here is 7 inches, so we can find this dimension here. This is the opposite side, this is the adjacent side, which would be a tangent. So we have the 50 degrees, so tangent of 50 degrees equals our opposite side is 7. We are looking for the adjacent side. Put that over 1 and we'll cross multiply and divide. So 1 times 7 is 7. 7 divided by the tangent of 50 gives us 5.87 inches. 5.874 will go. Inches. So what that means is this is 2.126 inches on each side. Which means that from here to here is 17.748 inches. Correct? 22 minus the 2.126 twice. So that's 17.748 inches across there. We know that from here to here is how far? 2 inches, right? Half of the diameter. So that's 2 inches there as well. So now we need to know the distance from here to there. That's going to come from, be the same as this distance here, so it'll come from that triangle. This angle of that triangle is 25, half of the 50, right? 50 is the whole thing. That's then half. That's our right angle. What's this side of the triangle? 2, right? Right here. So which side do we want to find? Do we want to find the hypotenuse or the adjacent? The adjacent side. Of course, 2 would be the opposite, so we're dealing with a tangent again. Tangent theta, opposite over adjacent. This time we know the angle, 25 degrees. Opposite side is 2, we are looking for the adjacent. Put this over 1 and we will cross multiply and divide. 1 times 2 is 2, divided by tangent of 25. We have 4.289. So that's 4.289 inches. So now we're going to take the 17.748. We're going to subtract the 4.289 twice. We're going to subtract the 2 inches twice. These are the difference of 5.1699 or 5.17 inches is the distance between those. What do you guys think? Is that doable? Yes. You look a little confused, Dylan. How about I give you a simpler one? Yeah. Let's go back to this problem. This one's for you, Dylan. So let's say we've got 80 degrees here. That's an 80-degree angle. And I'm going to make this a little bit easier on you. This is going to be 2 inches here. Let's say that this has a diameter of 6 inches. This is 8 inches here. I want to know, how far does this stick out beyond the edge of the block here? So what's that dimension right there? So whenever we see a problem like this, what we have to look at is, where are my right angles? Are there vertical and horizontal dimensions? What do? We have them here, 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 and here. But none of those right angles give us any right triangles. So the second place we would look for right angles is where there's a tangent to a circle. Well, right here, that line's tangent to the circle there. This line's tangent to the circle here. So a radius of the circle is going to make a right angle to that tangent at that point of tangency. That gives us a right triangle there. Whenever we connect the center of a circle to the point of a V, the intersection of tangents like that, it will always cut that angle in half. So this angle becomes half of the 80, or 40 degrees. We know that this side here is going to be how big? 3 inches, half of the 6. 6 is our diameter, the radius is 3. So I'm going to draw that triangle a little bigger. This is 3 inches and 40 degrees. How do I find this dimension? Everything come out okay? So how do we find this dimension here? This is the, according to that angle, this is the adjacent side. 3 is the opposite side. That's a tangent. So we fill in what we know. The angle is 40 degrees. Opposite is 3. We are looking for the adjacent side. So we put this over 1, and we'll cross multiply. 1 times 3 is 3, divided by the tangent of 40. Here's 3.575. This is 3.575 inches. So from here to here is the 3.575 inches. This is 2. From here out to the edge is how much? 3 inches. So we add those all up, we get 8.575 inches all the way out to here. So we subtract the 8 inches, we've got a difference of 0.575 inches is X. What do you think? Doable? Page 749 in your textbook. Exercise 35-2. 1 through 17, the odds. Deal with problems like this where you might have to look a little bit harder to find those triangles. You may have to find other triangles to find dimensions to get to those triangles. So I'll let you guys have the last 15 minutes to get started on those.